Hello children, welcome to My Dream. Today we are discussing the problem based on the mechanical properties of fluids. Yes, these are the questions which has been asked in the previous years of JEE Mains, as you know. Yes, a light cylindrical vessel is kept on a horizontal surface. Area of the base is A, and there is a hole of cross-sectional area, that is small a, is made just at the bottom of the side. This hole is made at the bottom of this side. The minimum coefficient of friction necessary to prevent sliding the vessel due to the impact of force emerging liquid. So first of all, you see the area of this base is A, this is at a height h. Then according to the equation of continuity, the volume of the liquid leaving the whole A, whole of area A with the velocity V. So according to the equation of continuity, AV is equals to the volume of the liquid flowing per second. The volume of the liquid flowing per second, or you can say the rate of flow, is given by small a into V, where V is the velocity. And the mass of the liquid leaving the hole, that is mass is equal to density into V, that is rho A into V. The force, now there is no sliding. The sliding is not possible only when whatever the force exerted by the fluid on the container must be equal to the force of friction. So force exerted by the water on the container is given by this. And delta m by delta t, that is already given to you, that is rho AV into V. So that is rho AV square. As I told you, it will not sliding the vessel when the force of friction is equals to the force exerted by the fluid on the container, and that is given by force of friction is equal to the force exerted by the liquid on the container, and F is equals to mu r and R is equals to mg. This is the mass of the container, rho AV square. And this is rho A. This is mg. And the height is area into height. Area into height. Area into height. Density, area into height, G. This is and height is of this is twice of V. Delta M by this is velocity rho AV square, container, yes, correct. This is rho AHG, there is no need to worry. The velocity of the fluid at a height this V square is equal to U square by 2GH. This is the velocity of this in this container because it is at a height A, it is at a height H. So G H rho, then mu is equal to twice of A by A, capital A. Remember one thing, you must know the velocity of this fluid in this container, so you can put the value of it. Now, option C is correct. Next question. A fluid is flowing through a horizontal pipe. Remember one thing, when we are talking about the Bernoulli principle, if H1 is equals to H2, so there is no need to discuss. P by rho plus half V square into GH is equal to A constant. No need to take H. So P1, next. A fluid is flowing through a horizontal pipe of varying cross section. The area of cross sections are different with velocity V at a point where the pressure is P. When the pressure is P, their velocity is V. This is the pressure and this is the capital P. Capital P and rho, these are the sometimes different. Rho V square. Where the pressure is P, yes, pressure is P. At the another point, the pressure is P by 2, where the velocity is V and the velocity is capital V. Here it is small v, here it is capital. If the density of the fluid is rho and the flow is streamlined, the value of V you want to know. So here the pressure at this end is P by rho plus half rho V square according to the Bernoulli principle. So this is P by 2 rho half capital V square. This is P by rho and this is P by 2 rho. So it will move here and you will get P by this. Now, half V square and half capital V square. Half cancel. Then you will get P by rho plus V square is equal to capital V square. So capital V is equals to P by rho plus V square. Take the square root. Which one is correct? P by rho. Yes, this one is correct. Option D is correct. So by following the Bernoulli principle, we can solve it. Next. Water flows through a horizontal tube. As I told you before, when a horizontal tube is given to you, there is no need to discuss H1 and H2. They will cancel. The pressure of the water changes. The pressure of water changes 700 Newton per meter square between A and B. These are the two sections. One of them is A, another one is B. Where the area of cross sections are 400 and this is 200. 40 centimeter square and 20 centimeter square. Find the rate of flow of the water through the tube. Yes. At this section, we can take the value of velocity VA and the area of cross section is taken as AA, and here you can take the velocity VB and the area of cross section, that is area of cross section of B. These are the velocities. So according to the equation of continuity, A into V is equal to a constant. So AA VA at this section A, AB VB at this cross section, at this cross section. So A, that is a 40, there is no need to convert into meter square because they will cancel out, and this is VA which is unknown, this is of 20 V. So VA is equals to VB by 2. VA is equal to VB by 2. Now, according to Bernoulli principle, at the section A, capital A, the pressure is P1 by rho plus half VA square, because the velocity is VA, that is equal to P2 by rho, and at the section B, the velocity is B, VB. Now, PA minus P1 minus P2, P1 minus P2 divided by rho, which is equal to half VB square minus VA square. Rho, the pressure difference is given to you, that is of 700. The difference in pressure is given to you, pressure of water changes and the density of water is given to you. It is multiplied by 2 also. Then VB square minus VA is of VB by 2. So it will become square of 2 4, 4 minus 1 3, 3 VB by 4 and there is a square. Now this is 7 2 5 7 4 ja 28, 7 4 ja 28 and 5 3 ja 15, which is equal to VB. Now you want to know the VB. If it is 30, then you will see 15 2 ja 30 and the square root of 30, square root of 2, 30 divided by 15, then you will get 2 and square of 2 is 1.414. It will be lesser than this, so you will get about 1.37 meter per second. You should convert into, because answers are given in centimeter, so 1.37 into 10 raised to 2 centimeters. Now, and you want to know the rate of flow. Rate of flow is given by AB into VB. You can do the calculation. I know, but you must do. The VBA, this is V 1.37 into 10 raised to 2 and the area of cross section is given to you, that is of 20. So you can write down 20 here. Then you will get, this is multiplied by 0, 4, 7, 2. Yes, this is about this. Yes. Okay. This is about calculative mistakes. कुछ नहीं है, nothing, कोई कैलकुलेशन नहीं, नियर बाई है ये बेटे. Yes. The water from a tap emerges vertically downward with an initial speed this. The initial speed is given to you and water from a tap emerges vertically downward with an initial speed this and the cross-sectional area of the tap is 10 raised to power minus 4. This is 10 raised to power minus 4 meter square. This is the correction, because this is the area. Assume that the pressure is constant through the stream of water and that the flow is streamline. The cross-sectional area of the stream you want to know at a depth 0.15 meter. So A1 V1 is equals to, according to equation of continuity, A into V is equals to a constant So A1 V1 is equals to A2 V2. The initial speed is given to you. Initial speed is given to you. This is very narrow, but आपको पढ़ाने के लिए बोलना पड़ता है बेटा. 10 raised to the power minus 4 is the area of cross section. I have corrected. This is 1.0. And you want to know the cross sectional area of the string. That is A2. Velocity V2 we didn't know. But as we have read, V2 square is equal to V1 square plus 2GH. Because the initial speed is given to you. So in place of this, you just make the square root and write down V1 square plus 2GH. This is of 10 raised to the power minus 4. This is V1. V1 is of 1. There is the square. 2 into 10 into what is the height? Height is of 0.15. It will become 3. And square root of 4 you know. A2 is equal to 10 raised to the power minus 4 divided by 2. Because the square root of 4. Is there any option? No. This is 2 into 10 raised to the power minus 5. This one is a 5 into 10 raised to the power minus 5. This one is the 5 into 10 raised to the power minus 4. But this is. So you can write down like this. So A2 will become 5 into 10 raised to the power minus 5. कुछ ऐसा होगा. Area of cross section इसका बेटे कितना -4 and इसका बेटे कितना मीटर स्क्वायर. Which one is correct? Option B is correct. Option B is. With the help of the equation of continuity, we have solved this problem. Now, the next question. Consider a water jar of radius. This is the water jar which has been shown here, of radius capital R. That has water filled up to a height h, and is kept on a stand of height this. Through a hole of radius, this is the hole of radius small r, which is much smaller than the radius of jar. The water leaks out and the stream of water coming down towards the ground. Here it is. Has a shape like funnel as shown in figure. If the radius of the cross section of the water stream, that is x, when it hits the ground. Yes, you can consider the velocity v1 here and v2 here. In this part, in this jar, this is the initial velocity. So according to the Bernoulli principle, half rho v1 square and the pressure, that is rho gh on this. This is the pressure exerted by this, and as the water flow in the streamline, This is V2. So V1 square is equal to 2GH is equal to V2 square. And V1 considered for this jar, which is at a height, the water or the fluid is at a height h. So you can write down twice of GH because there is a square. Otherwise, you can write down under root 2GH plus 2GH V2 square twice of G H plus H. This is the equation of continuity we have followed. Equation of continuity we will follow. This is the Bernoulli theorem. By using the Bernoulli theorem, we can discuss this. Now, we didn't know the velocity V2. What will we do? We follow the equation of continuity from this level to this level. So, according to the equation of continuity, area that is pi r square because the radius is small. Velocity is V1 is considered. Here the radius is considered Vx, pi x, and the velocity is V. V1 is given to you, that is pi r square, this is 2gh, and this is the V1 or the square of V1. So you can write down twice of G capital H. Now, V2 will become r square upon x square under root 2gh. Now you can put the value of V2 here. That is twice of G H plus small h. There is the square, so you can make the square r raised to power 4, x raised to power 4, and square of this, that is 2gh. You want to know x is raised to power 4, r raised to power 4, h capital H plus small h, x, r, bracket close, h plus r, small h, fourth root. This is x r h divided by h plus small h raised to power. This one is correct. A is correct. Yes. Water is filled in a container up to a height of. Water is filled in a container up to a height of 3. A small hole of area is punched in the wall of the container at a height of. This is in meter and this is in centimeter. So at a height of this 0.525, 52.5 centimeter, and this is in meter. The cross-sectional area of the container, that is A, and small a is the area of cross-section of this. Small a by capital A is very much smaller. Then square of V, you want to know the velocity at this level. So, V square is equals to 2GH divided by 1 minus A upon A whole square when we are discussing the venturi meter, then you will get this type of equation. So H, what is H? This is 1 minus 0.1 whole square. This is given to you. Height ये लेंगे बेटा ये लेंगे? No. The net height is H, that is 3 minus 0, 3.0 minus 0.525, which is 2.475. Which is 4.7. You can put the value of G 10 and this is 2.475. This is 24 2 ja. This is of 29.49.5. There is no effect of it. इसका कोई इफेक्ट नहीं पड़ेगा. So which one is correct? This is 49.50, which is about this. A large open tank has two holes in the wall. One is a square hole of side L at a depth y. There is a square from the top. Yes. And the other is a circular hole of radius r at a depth of 4y. When the tank is completely filled with water, the quantities of water flowing per second from both the holes are same. It means the rate of flow is same. The volume of the liquid flowing per second either from the square hole or the circular. When we are using the statement the rate of flow is same, it means we must follow the equation of continuity. That is A1 B1, we must follow the equation of continuity. A1 B1 is equal to A2 B2. Suppose we are considering the area of A2, that is A1, area of A, that is A2, velocity from this, that is V1, and from this V2. So there is a square hole, the area of the square is side square, so L square. At a depth y, there is a square, so that is v is equal to under root 2gh. But in place of h, you can write down y. Now we are talking about the circular hole. Area of the circular hole, that is pi r square. And the velocity is now, that is 2gh, but in place of h, you can write down 4y. Under root 2gy cancel. The square root of 4 will become 2, that is equal to this. So you want to know the radius, so r square is equal to L square upon 2 pi. So r is equal to, you can take the square root, that is, which one is correct? This is L upon 2, no, this is L, no, 2 pi L, no, this one is correct. Which one is correct? A option is correct. Next. The water from a tap emerges vertically with an initial speed. The initial speed the area of cross section if this is 10 raised to the power minus 4. This is correct. Meter square. And the speed is here, that is v1. This is the initial speed which is given to you. Assume the pressure is constant. Pressure at this level and this level is constant. It means P1 is equal to P, which will be cancelled. And that the flow is steady. The cross-sectional area of the stream 0.15 meter below. You want to know the area of cross-section of this part. And what will be the velocity at this part? Because by following the equation of continuity, A1 V1 is equal to A2 V2. The rate of flow of the liquid remain constant. And one another thing is also given to you, that is the pressure remains same in this question. So according to the equation of continuity, that is A1 V1 is equal to A2 V2. A1 is of 10 raised to the minus 4. At this time, the velocity is V1, that is 1.0. A2 we want to know. This is the initial velocity, this one is the final velocity. Attain some height. So V1 is square plus 2gh, and there is the square root. So you can write down A2, the value of V1, that is 1 square, this is 2 into 10 into 0.15, which is given to you here. So A2, that is 1 plus 3, that is 2A2. So which option is correct? A2 is equals to, A2 is equals to 10 raised to the power 4 divided by 2. Is there any option? Multiplied by 2, not divided by 2. What will you do? You can multiply it by 10 and divide it by 10. Then we will get this, and which is the correct option. C option is correct. Option C is correct. A train with cross-sectional area ST is moving with a speed Vt inside a long tunnel of cross-sectional area. This is a long tunnel. This is Vt, area of cross section, 4st. This is a long tunnel in which a train is moving like this with the velocity v. In front of the train flows backward between its sides. The walls of the tunnel also the air flows with respect to the train is steady and laminar. Take the ambient pressure and that inside the train be P naught. So P naught be the pressure. If the pressure in the region between the sides here of the train and the tunnel wall is P, then according to the equation of continuity, this is the area of cross section of the tunnel and this is the velocity and the train is moving with this area. So according to the equation of continuity, A1 V1 is equal to A2 V2. This is A1 V1. This is A2 V2. So area that is 4st and V1 that is V into V base T. What about the area of A2? This one, 4st minus this and this pressure exert on it. So 4st minus st and the velocity is v. 4st minus st, that is 3st, st to st cancel, then you will get 4 by 3 v. Now using the Bernoulli expression, at this end the pressure is P naught. You want to know the pressure is given to you here. What is the pressure difference is given in terms of A. Then P naught plus half Vt square into rho P is the pressure here, the velocity is V square and the density is this. So P naught minus P is equal to half rho V square minus Vt square. V square minus Vt square. The value of V is, you have, the value of V is calculated by the equation of continuity. So P naught minus P is equal to 1 by 2 rho. This is V and this is V square. So you can make the square 16 oblique 9 Vt square. 16 minus 9, then you will get 7. 7, yes, correct. 7 divided by 9 into Vt square. This is P naught minus P. Then you see, whatever the written over here, that is 7 by 2 rho Vt square, in place of n, you can write down 9, because n is equals to 9. Now, a horizontal pipe is given to you, P by rho plus half rho V squared GH is equal to a constant. A horizontal pipe is given to you. So, leave it. P by P plus half rho V square. So, P1 V1 order 1, P2 V2, इतना तो आपको लिखना ही पड़ेगा बिकॉज हॉरिजॉन्टल पाइप. अब आगे, the horizontal pipeline carries water in a streamline flow at a point along the pipe where the cross-sectional area is 10 cm square. The water velocity is this 1 meter per second and the pressure is 2000. The pressure of the water at the another point, this is the 10 centimeter square, this one is the 5 centimeter square, lies horizontally. So, the velocity is given to you here, that is 1 meter per second per second. Area of cross section of the second is this and velocity is this, which is unknown. So, according to the equation of continuity, A1 V1 is equals to A2 V2. A1 is of 10. There is no need to convert into meter square because centimeter square cancel. V1, that is 1. V2, this is of 5. So V2 is equal to 2 meter. Now, by using the equation of continuity, we have find the velocity at this section. So P1, that is of 2000, velocity density of water is given to you, that is of 1000. This is of V1 1 square. P2 I don't know, density of water this P square, V2 square, that is square of 2. this is of 500, this is of 2000, the pressure is P2, square of 4 divided by 2, then you will get 2, so it will become 2000, which will be cancelled. So the P2 is equals to pressure at the another end. The pressure at the another end, whose area of cross section is 5 centimeter square, and the velocity is 2 meter per second, that is of 500 Pascal. So which one is, there is no option. Next question. A tube has two area of cross section. A tube has two area of cross section as shown in figure. The diameter of the tube are 8 mm and 2 mm. The range of the water falling on a horizontal surface. It means you want to know this kind of the range, as you have read in the projectile motion. When we are talking about the projectile motion, you have already read it. When an object is thrown horizontally from the certain height, when an object is thrown horizontally from the certain height, then R is equal to Ux into T. Now, if the piston is moving with a constant velocity, the velocity of the piston is given. The piston की जो velocity है, that is v1, and which is of 0.14, that is 1/4. And the diameter is given to you. So radius, that is 4 mm. And as the piston is moving like this is R1, this is V1, the velocity of the piston. Here water comes out with the velocity V2, like this, and the area of cross section is A2, which can be written down in terms of radius, that is pi R2 square, and R2 is given to you, that is of 1 mm. So first of all, we can go through the equation of continuity. So A into V is equal to a constant. So A1 V1 is equal to A2 V2. This is the piston, and the area of the piston is pi R1 square, because the area of cross sections of a tube having the diameter, velocity is V1, pi R2 square V2. Here the speed is given to you 1/4, radius is of 4 mm, so there is no need. Square of this, pi cancelled, this is a 1 square, this is V2, 16 divided by 4, then you will get 4 meters. And this is the velocity, this one. This is the V2, 4, which is equal to Ux. And Simply you can say range is equals to V2 into T. As I told you before, when an object is thrown from a certain height horizontally, then you can add 2h by g, and the height is of 1.25 divided by 10. 1.25 into 2, that is 2.5. 2.5 4 ja 10. And square root of 4, that is 2. Then you will get 2 meters. Next. In this question, there is a lot of calculations. बहुत लंबी कैलकुलेशन है, करते हैं क्या कह रहा है. A non-viscous liquid of constant density. A non-viscous liquid of constant density that flows in a streamline along a tube of variable cross section. Cross sections are different. The tube is kept inclined in the vertical plane. The area of cross section of the tube, 2 points P and Q. There is a point P and this is Q. At the height of 2 meter and 5 are respectively, these areas are given. Areas are given to you. The velocity of the liquid at P is 1 meter. But you don't know the velocity at the section B. Here V is given to you, V1 is given to you, that is 1 meter per second. But V2 is unknown. First we can find out the V2 by using the equation of continuity. By using the equation of continuity, we can find out V2. Then find the work done per unit volume by the pressure and the gravity forces. Work done per unit volume by the gravity process. First of all, you can find out V2. V2 is equal to A1 upon A2, that is V1. A1 is of 4, A2 is of 8. सिंप्लीफाई कर रहा हूँ मैं, डायरेक्ट कर रहा हूँ आपके लिए. V1 is of 1, so it will become 0. Now you are having the value. Work done per unit volume by gravity that is rho g, and there is the difference in height, so you can write on h2 minus h2. H density, you know, density of water that is given to you, density is already given to you. This is the density of water. So density of water, this is of 5, this is of 2, that is of 5, this one is 2. Then you can write down 30 into 10 raised to power 3 joule per meter cube. This is the work done per unit volume by the gravity forces. Now, the work done per unit volume by the pressure. So, that is half rho V2 square minus V1 square. This is about the work done per unit volume by the pressure. लिखते थे ना हम पहले से, भूल गए होगा। P1 प्लस हाफ रो 1 स्क्वायर प्लस P2 माइनस हाफ P1 प्लस हाफ रो V2 स्क्वायर P1 माइनस P2 हाफ रो V2 square minus V1 square. So that's why I am saying to you, this is the work done per unit volume. This is of 1000, V2 is of 1 by 2. So you can write on 1 by 2. V1 is of 1, yes, Sira. This is 500, 1/4, 4 minus 3. Or you can say this is minus 3 by 8, 10 raised to power 3. This is 0.2. 8 3s are 24, 6, 8, 7 are. And this is with the sign negative. And if you want to know the net work done per unit volume, if you want to know the net work done per unit volume by this and that, then this is of positive and this one is of negative. So you can subtract it. So 30 minus 0.27, 10 raised to power 3 common, then you will get 29.73, 10 raised to power 3 Newton per meter square. No, sorry, joule per, yes. Yes, this is all about the mechanical properties of the fluids. We have already discussed the JEE mains questions which had been asked in the previous year. The next topic we will take in the new session, that is thermodynamics. In the next session we will discuss the thermodynamics. Okay, have a good day, children.